Hi, welcome to 9.1 Parabolas. So we're looking at parabolas in a brand new way, in a different way than we looked at them in Algebra 1 and Algebra 2 trig. So we're looking at parabolas as a conic section. And you see in the picture how if the plane slashed through at an angle into just one of the cones, a parabola would result. And so we're going to look at this parabola that we have on our notes, and we're going to add two things. Normally, we talk about a vertex, and for sure, there is a vertex in this parabola, and we can see pretty easily that it's right there on the origin. I'm going to give us what's called a focus. I am randomly giving it. Normally, we're going to have a distinct focus. We just can't randomly say, and I choose this as a focus. But for this time, I'm going to choose one. I want you to put a point there, and I want you to know that the distance, let's go ahead and put that still as the vertex. A point that you're going to see that's inside of the parabola is going to be called the focus. So instead of a foci, we only have a focus point because there's only one. And then we're also going to see something called a directrix. So when we're asked to sketch a parabola as a conic section, we're going to be asked to include the focus, the actual parabola, including the vertex, and the directrix. And we'll notice some things about the focus and the directrix. Mainly, the first thing we want to note is that the distance from the vertex to the focus point is P. So P represents the distance from the vertex to the focus. So you'll also see that the directrix is equidistant from the vertex, right? The vertex is in the center of the directrix and the focus. So if the focus is 4 up from the vertex, then the directrix, if the focus is 4 up from the vertex, and the directrix would be 4 down. So we want to go ahead and note that. We want to write that the directrix is the same distance from the vertex as the focus. Okay? So another way of saying that, if we wanted to see it a different way, the vertex is located midway between the focus and directrix. Now, you know, because this is actually our fourth conic section that we were looking at. We looked at the circle, the ellipse, and the hyperbola first. We have to start off with some vocab that we agree on some definitions. So we're using that space with the picture to write all of this stuff. Okay, I want you to notice the definition. So the set of all points in a plane that are the same distance from a given point called the focus, and a given line called the directrix. So let's just have a little bit of fun looking at this picture because it's pretty much drawn to scale. Well, we'll see if it's drawn to scale. So let's pick a hot green, and let's just pick a random point, like this point. If this was drawn to scale, basically the parabola is all the set of points that have the same distance from the focus as they do from the directrix. That looks kind of convincing, right? So let's say that this distance, it's kind of hard to see, but let's just say this was somewhere a little bit below 4. Then the distance, this distance, distance 1, is the same as this distance. And we could pick a different point, like we could pick this point right here, right? And that would say that this distance is the same as this distance. Doesn't look quite as believable, but if this were drawn to scale, we would see that this parabola is made up of all the points that are equidistant from the focus and the directrix. Let's just make everything bright green. Okay, so let's move past the definitions and let's see what it's going to look like as we work with it. Now, I know I included this on your notes. When I used to teach honors pre-calc, I loved deriving formulas, and it just seems like we don't do that enough in regular pre-calc. But if you're interested in how did we come up with the standard form of a parabola, which you will see right here, our standard form is right here, then you can study this, this derivation. It's using the distance formula from this point to this point, and it's setting that distance equal to the distance from this point to this point. So from this point to this point should be equidistant to this point, which of course is not drawn to scale, so it doesn't look like that. So if you have fun thinking about that, go ahead and look at that. And then I also have on your notes, I just kind of, I don't know, it looks like I did all the work for you, but I had the different forms of a parabola equation. So let's stop and look at the first one first, okay? When we look at parabolas as a conic section, we have parabolas that can be up and down like this, or we have parabolas that can be side to side, you know, or on their sides. And looking at parabolas as quadratics, of course, we couldn't have this, right, because these aren't functions. So they're parabolas, but they are not quadratics. So think about that for a second. But let's go back to the blue. When we look at this, this is our standard equation right here that we need to memorize. And we can stop and think, well, wait a second. Back in quadratic land, when we saw y equals x squared, we knew that meant that we were dealing with a quadratic that was either up, or if there was negative in front of the x squared, or down. So we can know the same thing. If we see a formula where the x is squared, we can automatically know that we have an up or down quadratic. Conversely, if we look at this one where the y squared exists, then we know, when we see a y squared, that automatically tells me that I'm dealing with a quadratic that's not up or down. And the only other option, I'm sorry, not a quadratic, I'm dealing with a parabola that's not up or down. The only other option would be laying down, either opening up to the left or opening up to the right. And then, of course, we take our two basic equations and we insert the h and the k like we do right here in red and in black. We do that when the vertex is off the origin. All right, so I know, right? We've got a p. Well, we know we've got a p. We have a p in the equation, and that p, we have to remind ourselves, stands for the distance from the vertex to the focus point. So that's why there is a p in the formula. That's what it refers to. And so you know what? Let's just start using it, and I think the formulas will start to make sense. All right, find the standard form of the equation. Hold on, I just want to make sure that we're still going. We are. So find the standard form of the equation of the parabola with the vertex at the origin and the focus at 0, 4. You know what I'm going to say, right? When they give me info, I am going to sketch it. So I'm going to make my vertex be on the origin, and my focus is up 0. 0, I don't go left or right, but I go up 4. So I automatically know, if I'm going to sketch it, that my parabola is going to be upward. So I know, and it's also, well, it's upward. So it's either the up or down one, which means that we go to the x squared equals 4py. Now, if I notice that the vertex was not on the origin, then I would insert the h with the x and the k with the y. And so I'm going to stop and be like, okay, I'm almost there, right? In every formula, we have to have a y, and we have to have an x as far as conic section formulas. And so really, all that we have to insert is to notice that our p, our distance from the vertex to the focus, is 4. So that's all we do. As we plug in a 4 for p, and we say x squared is equal to 4 times 4y. So x squared equals 16y. I want you to not give in to the urge that says solve for y, because for parabolas as a conic section, this is our standard form. This is in simplified form. Don't go dividing both sides by 16. Stop. Leave it in standard form for the conic section parabola. All right, let's look at example 2. So find the standard form of the equation of the parabola with the vertex at 1, 0 and the focus at 2, 0. So I'm going to do the same thing, right? I'm going to sketch it. So my vertex is off the origin, so that means I'm going to have to keep my h's and k's, right, or add my h's and k's in. So my vertex is 1, 0, and my focus is 2, 0. I know that my focus is always inside my parabola, so my parabola is going to open up to the right. Now, notice this is just a sketch. I really don't know how wide or how narrow my parabola is, and I don't care. I'm just making a sketch to help me know which formula to use. So if it's a laying down, a left or right, stepping on my mic, sorry. If it's a laying down left or right, I know that I put a y squared here, and then I have the 4px here. And I know what you're saying. You're saying, wait a minute, Miss Overby, the vertex is not on the origin. So what I do is I tell myself, you know what, I have so many things to remember for this test. I'm really just going to memorize these two formulas, and then if I need an h or a k, I'll just put them in. All right, so that's what I do when I see that I have a laying down. I remind myself, oh, that's y squared. And then I'm going to go back in and put the k in with the y and put the h in with the x. All right, so I'm just going to start filling things in. So I notice that my vertex, change up the color, my vertex is 1, 0. And so I'm going to put the 0 is the k part. So I'm going to write it down, do that extra step so when you're looking at your notes it makes sense. I've got the 4, I'm going to plug in the p, and then for my h is 1, so I'll have x minus 1. And then I have to stop and remind myself that the distance p is a distance from the vertex to the focus, and that's 1, so I'm going to plug 1 in there. And then I'm just going to simplify it. So, of course, 1 minus 0 is 1, so I have y squared equals 4 times 1 is 4, and then I have x minus 1. Now, I know what you're thinking. Shouldn't we distribute that forward? No, we shouldn't. This is simplified standard form for a parabola. That's a conic section. And we can look at it real quickly. We can gain a lot of knowledge from it, right? That y squared tells us that it's going to be a laying down parabola. That 4 tells us, because it's positive, that it's actually going to be laying down looking to the right. And this -1 tells us that, oops, our vertex is 0, 1. Or I'm sorry, man, I fell for that, didn't I? Because the x is second, we have to be really careful. The h still comes first, so 1, 0. So when leaving it in that standard form tells us a lot. All right, let's look at the next one. Find the vertex, focus, and directrix of the parabola. And this is not in standard form, right? So we're going to make it in standard form by simply subtracting this from both sides. I don't know why I'm writing it 2 times. Probably because I just got done teaching algebra. All right, so that gets rid of that. There we go. Do you feel like we're in Algebra 1 right now? All right, so here I can see that this is in standard form. And I gain a lot of information from just looking at it, right? This part, because we have x squared, tells me that we have an up or down parabola, right? This part, because I see a negative here, well, we'll get to that. It's going to be a downward facing, right? And then the 1 and 3 tell me that my vertex is not on the origin. So here we go. Let's go ahead and start with the vertex. That's probably the easiest thing to do. So let me switch to green, and I can see that my vertex, right, is going to be -1, -3. So I'll write that. On the test, of course, we'll have lines for you to write it separately. So we'll have -1, -3. There we go. That's our vertex. And then the focus. So here's how we're going to do the focus. We know that this formula, I'm going to write down the formula underneath, is x minus h squared equals 4p y minus k. All right, so we already got the -1 and the -3. But this 4p right here is the same thing as this -8 right here. Can you guys see that? That these things represent the same value. So what we're going to do is we're going to set them equal to each other. We're going to say -8 is in place of the 4p for my formula. And I'm going to divide both sides by 4 to get that p is equal to -2. All right. Now I know what you're saying. You're like, Miss Overby, P is distance. How can distance be a negative, right? So the negative is going to tell us direction, kind of like velocity when you do physics. That negative tells you the direction. Same thing here. The distance is 2, but we already know it's either up or down. So the distance is still 2, but the negative tells me go down from the vertex. So here's my vertex at, I'm going to hit a 1, -3. So I'm going to go ahead and go down 2. And can you tell, because the directrix went down, that the parabola itself is going to open downward? Now, do I care how wide this parabola is when you draw it? I do not. We're not going to take the time to draw it to scale as far as the width or the narrowness of the parabola. That's not our focus. Ha ha ha, our focus. Okay. Man, why do I enjoy the corny jokes? I don't know. All right, so we're almost done, right? If that's our, we've got our vertex. Let me use a different color. Let's use red. So we've got our vertex right here at -1, -3. Why does it look like it's not exactly on there? But it is. And then we have our focus here. So our focus is at -1, -5, right? So we're going to write that for the focus, -1, -5. And then our directrix needs to be, and if the focus was down to, our directrix is going to be up to from the vertex. Remember, the vertex is midway between the focus point and the directrix. So any line that's horizontal starts with y equals, and so the directrix will be y equals, and it goes through -1, so it's y equals -1. All right, are we good? I hope. All right, let's look at example 4. Find the vertex, focus, and directrix of the parabola given by, wow, what do you think we're going to have to do? That's right, we're going to have to complete the square. So the first thing we're going to notice is that we have an x squared, but we don't have a y squared, right? And that's normal for parabolas, right? I think you probably have picked up on the fact that all those circles, ellipses, and hyperbolas all have x squareds and y squareds. Parabolas only have one or the other. And so in this case, we're going to focus on completing the square with our x's, and we're going to kick the y's out to the other side. So what we're going to do is we're going to gather up x squared minus 2x. We're going to leave a blank. We're going to kick the 16y to the other side, and we're going to add the 31 as well. So now let's complete the square. And the reason why, right, I think about, obviously, I have an h and a k. I think about the formula that I'm heading for. I'm going to write it up here. Maybe I'll write it over here. What I'm heading for is x minus h squared equals 4p y minus k. All right, so that's what I'm heading for. So I know that on the left side, I've got to have a perfect square trinomial that I factor so that it looks like that, x minus h squared. So here I go. Half of 2 is 1. 1 squared is 1. We just dropped a 1 in. So let's drop a 1 in on the other side. Now we created a perfect square trinomial. I know we factor that as x minus 1 times x minus 1, so that's x minus 1 squared. And then let's combine these two terms, these like terms, so we have 16y plus 32. We're almost there, right? The left side looks good. The right side needs to look like this. I need to see some parentheses, don't I? So let's look at 16y and 32, and let's pull out the GCF. We're going to pull out 16, right? And we end up with y plus 2. So now finally we can sit back and breathe until we do the next example. And we can see that now it's in standard form. All right, so what does that mean? It asked us to find all these things. You know I'm going to sketch because I'm a sucker for a good sketch. But here we go. They asked for the vertex. I can easily find the vertex from my h and my k, right? It's always the opposite of what we see. So my vertex is going to be 1, -2. I'm going to quickly sketch that. 1, -2, there's my vertex. And then to find the focus, I know that the 16 is the same. That 16 matches up to where the 4p is. I'm going to set 16 equal to 4p. Divide both sides by 4. P equals 4. Which is the distance, and it's a positive 4. We already know because it's x squared that it's either an up or down parabola. And when we see that p is positive, we know that the focus is up. So we're going to move up 1, 2, 3, 4. And there's our focus right there. And then we'll go ahead and say our focus is 1, 2. And then let's, I almost said focus on the directrix, but okay. Let's pick green and let's go ahead and find the directrix. If the focus is 4 up from the vertex and the directrix is 4 down. So 1, 2, 3, 4. All horizontal lines start with y equals, and we look at the y-axis, what number it's going through, and it's 1, 2, 3, 4, 5, 6, so negative 6. So y equals negative 6. And then if we wanted to complete our sketch, we would show how the parabola includes the focus inside of it, and the directrix is on the outside, with the vertex being equidistant between those two. Okay, only one more to go. I think after we've made it through ellipses and hyperbolas, parabolas seem a little bit easier. I'm hoping that you feel that way. So write the standard form of the equation of the parabola with focus at 1, 2 and the directrix at x equals 3. There are a lot of you that when given information still don't draw a sketch. Please, please, please draw a sketch. Right? A picture says 1,000 words. A visual, most of us, even though some of us know that we're strong auditorially, most of us benefit from a visual. So give yourself that gift. Here we go. My focus is 1, 2. So we'll go over 1 up 2. So there's my focus. Now we don't know, just given the focus, whether we have an up or down parabola or a sideways parabola looking to the left or looking to the right. But given the directrix at x equals 3, I know any line that starts with x equals, and then there's a constant on the other side, that's a vertical line. So I'll go to the x-axis, find 3, and put, boop, there is my directrix. I know because I was listening when I talked that my vertex is located exactly between my focus and my directrix. So my vertex is going to be, let me get rid of that red, there we go. My vertex is going to be right in between them. And the coordinate point of that vertex would be 1 over 2, up 2. So my vertex, let's write that down because that's going to be important. Vertex is 2, 2, because it's in the middle of my focus and my directrix. I can go ahead and do a quick sketch, right? Finish it. I don't really know how wide it is unless I went ahead and plugged a certain point into the equation, and we're not going to do that. So, but we're not done yet. So let's see. Vertex is good to know. I also need to know what P is, and P is the distance from the vertex to the focus. Okay, so we're going to include in our distance, we're going to include that it is 1, but it's also 1 to the left. So we're going to include direction in there. So P is going to be -1. All right, so here we go. I know I have an H and K. I know I have a laying down parabola. So I know that I will be using the formula with the Y here. That's squared. And like that. And so I'm going to go ahead and put my vertex in. I'll put the 2 there, and I'll also put the 2 there. And then I'll stop and realize that my P, although the distance is 1 from my vertex to my focus, it's to the left, and so the direction is negative. So that's going to be, P is -1. So if we plug in -1, 4 times -1 gives me a -4. And there you have it. That is the equation of this parabola. I'm just taking a second look at it just to make sure I have it right. Focus is at 1, 2. That means the directrix is behind it because yep, we're good to go. All right, you see your homework on the bottom. Please remember that the practice is important. Our brain is not designed to learn new things and then move on without practicing. If you do that, you will not retain this new learning that you just experienced for the last, how long? 24 minutes. Can I talk so there could be an even 25? Should I do that? No, probably not. Thanks for joining me. Have fun practicing.